Greetings, science fam. We're going to be doing some practice on one-step mole problems. So this is the official worksheet number 1 for one-step mole problems. If we take a look at number 1 here, we have 10.5 grams of oxygen, O2. We want to convert that into moles. So first of all, what we need to do is look on our mole map. If we're starting with grams, remember that mass is what we measure in grams. So it looks like we're starting with Mass Island, and we're going to head over to moles. So if we're going to head over to Mole Island, we're going to use this arrow right here, which means we're going to use this conversion factor. So now that we have that, let's set up our problem. To set up our problem, we always start with what is given. So I'm going to have 10.5 grams of oxygen. Now that I have that, remember I'm going to multiply and draw a line, and I'm now going to use this conversion factor. On top, it gives me a number. It says 1 mole. Since it's 1 mole, and we're talking about that substance, I'm going to call it 1 mole of oxygen. But on the bottom, you notice it says molar mass. If you remember, molar mass is the mass of that object when you have 1 mole of it. So basically, it's the mass on the periodic table in grams. So since I have oxygen, O2, it's really just oxygen plus oxygen. If you look on the periodic table, a mole of oxygen is 16 grams. So if you have 2 of them, 16 plus 16 is 32 grams for every mole. Okay? So the molar mass in the bottom is going to be 32 grams of oxygen. Why? Because we just said 2 oxygens on the periodic table is 16 plus 16. Now here's the beauty of it. Since we use this map, we notice that in the numerator is grams of oxygen and the denominator is grams of oxygen. So they cancel out. Now that they're canceled out, all that left are units of moles of oxygen. And that's what we wanted. So by using this map, it actually helped us convert. So now what this problem becomes is, remember, multiply by the top, divide by the bottom. So this problem is going to be 10.5 times the top, which is 1, divided by the bottom, which is 32. When you put that into your calculator, what you end up getting is about 0.33 moles of oxygen. You notice that I use MOL for moles. That's a shortcut, all right, or a nickname for moles. Instead of putting MOLES, you can just put MOL. All right, but in the end, that allowed you to do that problem and get our answer, which was in moles for moles of oxygen. So conversion number 1, complete. Let's look at question number 2. We're starting with 16.5 moles of water. So if you're starting with moles, you're going to start at Mole Island. Now it wants us to convert it to grams. If you remember, grams is Mass Island. So we're going to go from moles to mass, so we have to use the bottom bridge to get to Mass Island, which means we're going to have to use this conversion factor. No problem. Let's start by writing out what we're given. We know we are given 16.5 moles of water. Now that I have that, I'm going to draw a multiplication sign and a line because I'm now going to include my conversion factor. Notice on the bottom of that conversion factor, it says 1 mole, and I'm going to leave it as H2O because that's the object we're talking about. And on top, it says molar mass. Remember, molar mass is the mass off the periodic table in grams. So if it's H2O, it would be hydrogen plus oxygen. Well, if you look on the periodic table, at least mine, each hydrogen is let me write that a little bit better for you, 1.01 grams for every mole, and oxygen is 16. So when I add up 1.01 plus 1.01 plus 16, I end up with about 80.02 grams for every mole of water. So that's why for molar mass, I'm going to put on top 18.2 grams of water. So now we have that set up. We notice that moles of water is in the numerator and the denominator, so those cancel out. So that means all that's left is grams of water, which is exactly what you were trying to solve for. So grams of water is what our units are going to be in. Now let's just do our math problem. Remember, you always start with the number you're given, multiply by the top, divide by the bottom. So that's going to be 16.5 times 18.2 divided by 1. When you put that through your calculator, the number you end up getting is about 293.33. So your answer ends up being 293.33 grams of water, all because you used your mole map to help you convert. If we look at number 3, it says you have 10 molecules of SO2. Well, molecules at first, you might be like, wait, where is that on the mole map? But it says right here, molecules. So you must be starting at particle island. And then it says it wants you to convert to moles. So to do that, you're going to have to go to mole island. So the bridge you're going to need to use is the top number. All right, so this is the conversion factor we have to use. So as always, we're going to start out with the number we're given. In this case, it's molecules. So I'm going to say 10 molecules. And to do that, I'm just going to use MC for short for molecules, so I don't have to write out the whole word. So I've got 10 MCs of SO2. I'm going to draw my multiplication sign in a line. And now I'm going to use up top here my conversion factor. On top it says to use 1 mole. I'll use MOL for a shortcut. Remember, we're still talking about the same substance, so it's SO2. And then on the bottom, it says 6.02 times 10 to the 23rd particles. Remember, 6.02 times 10 to the 23rd is how much a mole equals in pieces. And the reason it says particles is because we don't know if we're talking about atoms, molecules, or formula units. But we know we're talking about molecules. It says so in the problem. So we're going to label that not as particles, but as 6.02 times 10 to the 23rd MC for molecules. Let's make sure that we still call it SO2, because that's what it is. And lo and behold, let's take a look at how the work helps us figure out and cancel out. So on the numerator, I've got molecules of SO2. Denominator, molecules of SO2. So they canceled. So the only units that are left are moles of SO2, which is exactly what I'm looking for. So the good news is we set up our problem right because I'm left with the units I'm looking for. Now we just have to do the first number times the top divided by the bottom. Move that up just a little bit. Now that I have that, let's write that out. So it's going to be 10 times 1 divided by 6.02 times 10 to the 23rd. Now all of us are going to be using different calculators, but it is important to be able to put 6.02 times 10 to the 23rd into your scientific calculator correctly. I have linked videos in the class on how to do it on your TI-83, on like a smartphone, a TI-84, and a TI-30. But you really should be using, for most of them, a value that is like, it looks like EE for scientific notation. And you got to learn how to put it in properly, all right? You as an educated human can figure that out, and you can reach out to me in class if you need help. But a lot of people don't take the time to learn how to put this properly in their calculator, and they end up getting the wrong answer a lot. All right, but let's do it. 10 times 1 divided by 6.02 times 10 to the 23rd. The number I end up getting is 1.66 times 10 to the negative 23rd moles of SO2. 10 to the negative 23rd means that that period on 1.66 would go to the left 23 times. So is this a really small number? Yeah, absolutely. So keep that in mind, that what this scientific notation means. It's important because a lot of people don't take the time to understand it, and they don't realize if it's a big or small number. A negative exponent means that it's extremely small of a number. If it's a positive exponent, it means it's a really large number. So scientific notation helps us figure out big and little numbers and writing them. All right, so those are the first 3 problems. Let's clean up and go to number 4. Number 4 has us starting at 78,980 grams for something called H3PO4, phosphoric acid. So since it's in grams, remember that's going to be our mass. Okay, no problem there. That's our mass. And we want to convert that to moles. So I'm going to end up with mole island. Perfect. Now that I'm going from mass to moles, I'm starting with mass. I have to use this top bridge, so I'm going to use this conversion factor. Well, let's do it. To start, I'm always going to use the number I'm given, so 78,980, and that's grams. of phosphoric acid, H3PO4. Now, as always, I'm going to draw a multiplication sign and a line. If you see, it says put 1 mole on top, so I'm going to follow my map, 1 mole, and it's of H3PO4. I want to get in the habit of writing out what I'm looking at because that'll help us when we get into even larger, longer problems. These are just the beginning. On the bottom is molar mass. So to get the molar mass, remember it's the mass off the periodic table. So I have 3 hydrogens, 1 phosphorus, and 4 oxygens. I'm going to go on the periodic table and add all of those up individually. And when I do that, I get around 98 grams of H3PO4. Now that I have that, I can start looking to make sure my conversions worked out. Numerator, grams of H3PO4. Denominator, grams of H3PO4. Those units cancel out, and I'm left with just moles on top, which is exactly what I was trying for. So my work looks good. Remember, I'm going to multiply by the top, the first number times the top, divided by the bottom. So when I do 78,980 times 1 divided by 98, I end up getting about 805.9 moles of H3PO4. So we could successfully converted. Nice work. Looking at number 5, looks like we're starting with 764 moles of C6H12. If we're going to look moles, that means we're starting here in the mole map. We're going to go to molecules. Molecules you can see right here under particles. So it looks like we're going to go to particle island. So if we're starting at moles and going to particle island, we have to take this bridge, which means we have to use this bottom conversion factor. No problem. Let's do it. Let's start with the number we're given, 764 moles of C6H12. As always, draw the line with the multiplication problem. Now we're going to use our conversion factor to figure it out. The top number is told to us. It's 6.02 times 10 to the 23rd. Remember, it's particles. So since we're looking for molecules, that's what we want to solve this for, MC, molecules of C6H12. All right? And then on the bottom, the conversion factor says 1 mole of C6H12. Perfect. Now that we have that, let's check our work to make sure we're sitting well. Moles of C6H12 in the numerator and denominator cancel out. So we're left with MC, molecules of C6H12. That's what we're trying to solve for. So our work looks good. We're just going to take our first number, multiply by the top, divided by the bottom. So that's going to be 764 times Avogadro's number, 6.02 times 10 to the 23rd, divided by 1. Remember, make sure you put 6.02 times 10 to the 23rd in your calculator properly. If you don't use the EE function for scientific notation, you might be getting the wrong answer occasionally, so you have to be careful. But now that we did that, 764 times Avogadro's number, and we divided it by the simple number of 1, we end up getting about 4.6 times 10 to the 26th power. Remember, that's units of MC, molecules, and the compound is C6H12. By the way, that C6H12 is called cyclohexane, and that is often used as a solvent, which means that it's good for dissolving things in the industry. And also, it's a starting point to work with other objects that eventually are led to making nylon. So, just so you know, that's cyclohexane. Looking at number 6, we get 451,000 grams of CH3OH, which is methanol, which is a type of alcohol. Not one that humans would consume or drink, but one that often is used as a solvent. All right, so methanol, 451,000 grams of it. Remember, mass is grams, so we're starting at mass island, and we want to convert to mole island. So we're going to take that top bridge over to mole island, which means we're going to use our mole map on the top for the conversion factor. Let's start out by writing what we're given. 451,000 grams of methanol, we are now going to draw the line and a multiplication problem. Because of the conversion factor, we're going to put 1 mole on top. That's 1 mole of methanol. We're still talking about the same object. On the bottom, we want the molar mass. Remember, molar mass is just off the periodic table. So there's 1 carbon plus 3 hydrogens plus another oxygen plus another hydrogen. So go on the periodic table, add all of those up. And once you do, you should be able to see just how much that molar mass is. I ended up with about 32.05 grams of CH3OH. All right, so 32.05 grams is the molar mass. Let's take a look at our work. Make sure that our work makes sense. Whoops, sorry, didn't mean to move that like that. Let's do our grams of CH3OH. They cancel out, numerator and denominator, right? So we're left with moles of CH3OH, and that's what we were trying to solve. So that's good. We're going to do our first number times our top divided by our bottom. So 451,000 times 1 divided by 32.05. And what you end up getting is about 14,071.8 moles of CH3OH. And remember, we knew it was moles of CH3OH because you always end with a certain amount of material with a certain unit after you cancel out the numerator and denominator from the step behind. All right, that was number 6. Looking at number 7, we're starting with grams of sodium hydroxide. Sodium hydroxide, by the way, is a strong base. It can be used for things like Drano to clean out our pipes in that. It can eat through like human hair, so it's really, really basic. But anyways, you have 43,256 grams of it about. So if it's grams, we know we're starting at mass island, and if we're converting to moles, that means we're going to mole island. Now that we know that, mass to moles, we're going to use our top bridge, so we're going to use this conversion factor. So let's write down the numbers we have. 43,256.06 grams. That's of sodium hydroxide. Now that we have what we started with, we hit the multiplication sign and draw the line. And now we're going to use our conversion factor. On top it says to use 1 mole. So I'm going to use 1 mole. On the bottom it says molar mass. Molar mass, remember, is just added up off the periodic table. 1 sodium plus 1 oxygen plus 1 hydrogen. When you add all of that up, you end up getting a nice round number of about 40 grams. So it's about 40 grams of sodium hydroxide for every 1 mole of it. And that's all your conversion factor is just a fraction saying that 1 mole of sodium hydroxide is the same as 40 grams of it. That's why you can write them over each other. If we want to double check our work, which is always a smart idea, grams of sodium hydroxide is in the numerator and denominator, so those cancel out. Moles of sodium hydroxide are left on top, and you were looking for moles. So this looks like this is a great setup. Now that we have that, let's take the number that we start with, always multiply by the top and divide by the bottom. So that's going to be 43,256.06 grams times 1 divided by 40. And when you put that in your calculator, the number you get out is 1,081.40. And remember that we have to label that, and that's moles of sodium hydroxide, NaOH. The reason you knew what the units were is because the very last step, moles of sodium hydroxide are the only things left that haven't canceled out. So there you go. That was number 7.